Does a cool condenser outlet temperature indicate good condenser performance?
When we have condensers arranged in parallel, a low condenser outlet temperature may actually indicate very bad performance. I have here two identical condensers in parallel. The condensers are the same, and the piping is the same, at least superficially. But let's presume there's some obstruction in the outlet from condenser A. As the liquid flows across that obstruction, it undergoes a small pressure drop, 1/10 of a pound. But 1/10 of a pound of pressure drop for something like butane, that might be about 6 inches of liquid. And that will cause the liquid level to be driven up appreciably in the channel head of condenser A. There will be less tubes exposed to the condensing vapors. Therefore, the rate of condensation of vapor in A will go down. And since the condensers A and B are arranged in parallel, it follows that the vapor flow that was condensing in A before it was exposed to condensate back up, that vapor will then be pushed into B. So the condenser duty of B will go up, and it will have a tendency to develop a higher condenser outlet temperature, well, primarily because it's doing a bigger load of condensation than condenser A. On the other hand, condenser A, which is handling less than half the load, will have a low condenser outlet temperature because as the liquid backs up on the channel head side and the tube side of A, the liquid, after it condenses from a vapor phase to a liquid phase, is then subcooled due to condensate backup. And hence the outlet temperature from A is 90, the outlet temperature from B is 120. Ordinarily one would think, B is doing a poor job and A is doing a better job, but as you can see from my sketch, just the reverse is true. How does one identify this problem of condensate backup in the field? Well, simply take your infrared temperature gun and look for a temperature gradient on the exterior shell side of the condenser that then would correspond to a liquid vapor interface inside condenser. And as you can see, that interface would be higher in A than B, and then that is the way I would do it in the field with my infrared temperature gun.